Alright, so this video is about angle measure. Alright, so before we get talk about angle measure, you have to know what a ray is. Alright, so a ray is part of a line. So basically, if you think about a line having two ends that goes on forever, a ray doesn't have two ends that go on forever, but one. So this end would be a point. And let's say this is point R, and this point is S. So this is ray RS. And we describe it with the two letters that's on that ray, and above it is a ray, a line segment with an arrow on one end. And it's always named using the letter, starting with the letter for its endpoint. So whatever that letter is, you name it there. And it could be named with any other letter along there. Let's say this is T. You can call this ray RS, you can call it ray RT. And you're both describing the same ray. You couldn't call it ray ST because that would begin here and it wouldn't include point R and all the points in between there. So anyway, so it begins, is named with its endpoint, and it goes in one direction forever. All right, so if you understand ray, we can start thinking about what a line is. What an angle is. So an angle is, by definition, an angle is formed by two non-collinear rays with a common endpoint. So by definition, an angle looks like this. So you got a ray. So this is ray TW. And by saying non-collinear, it can't be the same line as that ray. So it has to go in a different direction. Let's call this one TQ. Alright, so by definition, this is an angle. It's two non-collinear rays. The two rays are called sides to the angle. So this is one side of the angle, this is the second side of the angle. So two rays are called the sides of the angle. And you would name this angle, this is angle. This is angle W, angle WTQ. What's important about naming an angle is the middle letter has to be the same as the vertex, and the vertex is the place it bends. So whatever that middle letter is, it has to be the middle letter when you name it. So this actually reads angle WTQ. That's how it actually reads in words. Another way you see angles a lot is this. I'm going to erase some of this stuff because I'm going to need the space. So another way you're going to see angles represented is things like this. This angle could be written as a little m and then the angle symbol WTQ. All right. The only difference between both of these sentences, this says angle WTQ, and that little m means measure. So this reads measure of angle WTQ. That's all that means. So whenever you see a little m there, they're saying the measure of the angle WTQ. And whenever they say the measure of the angle, they're talking about how big the angle is. So you might have an angle that say, I'm going to make up a number, this might be 90 degrees. All right, so we'll see measure of angle WTQ equals 90 degrees. All right, so that's another way angles are represented. All right, and how we describe them. All right, I'm about to erase all of this stuff, so if you need it, I will copy it. Another important thing about angles are the angles are measured in degrees. And degrees are the little symbol we see, like 15 degrees. Degrees tell you it's a little circle up there that's describing that's the unit of measure we're in. It means degrees. All right, so understanding that, this is called a protractor. Protractor. And we use that to measure angles. I'll get a good estimate of what the angle is. Along there, you got two angles, measurements. You got 180 degrees, 1 to 70 degrees, 1 to 60 degrees, 1 to 30 degrees. Or you consider it 0, 10, 20, 30 degrees, 40 degrees, 50 degrees, and so forth. It depends on how you're looking at the angle. All right, so there's 4 types of angles, just so you know. One of the types are, well, all 4 types are, and you probably already know this, but you got the acute angle, and you have an obtuse angle, and you have a right angle over here. And you have a straight angle. All right, so acute angle, you probably know, I'm telling you anyway. Acute angle is less than -90 degrees. So acute angles you think are kind of small. Acute, thinking small, little thin angles, just something that we know is less than 90 degrees. Obtuse angles are different because they are greater than 90 degrees, greater than 90 degrees. So they're really wide. So it's something that's bigger than 90. So this is obtuse. A right angle equals 90 degrees. All right, so a right angle, a good example of a right angle is the corner of a square. So if I gave you a right angle, they usually put a little square on the inside of it to denote that it's a right angle, all right, because it is related to a square. But a right angle is usually represented with a little square on the inside the box, but that square tells you this is a 90-degree angle. All right, and the last one is a straight angle. Straight angle is pretty boring because it's just a straight line. Straight angle equals 180 degrees. All right, so this whole angle is itself 180 degrees. So it's a straight angle. So those are the 4 different types of angles. And how we use a protractor to measure it is this. Basically, I need to erase all this stuff about the types of angles. So if that was news to you, I'd write it down. If you already knew that, you don't need to write it down. All right, so let's suppose you want to measure an angle. All right, let's say the angle looked like this. At some side like this, another side like that, and I wanted to measure it, right? So basically what you do is you take your protractor and you place your protractor, you pick this point right here of the protractor, right there on the corner of the angle, all right? So, because I can do this with my computer, I'm just going to take the angle and move it on top of my protractor. All right, so now it's on top of the protractor. And what you want to do is you want to line up one of the sides, I'm going to choose this bottom side, to line up with this line here. And you want the vertex to be right there on the center of the protractor. You might have a hole there, but use it someplace that you can easily see this is the center of the protractor. And wherever the other line falls, tells you where the angle is. So this line falls right along this. If I kept extending the angle, it would go right through 60 and 120. Well, 120 degrees is bigger than 90. So that would mean obtuse. Now look at this. Does this angle look obtuse? Well, obtuse angles are really big. And that's definitely not obtuse. So this is a small angle. So it's acute. So I'll have to look at the acute number. The acute number is 60 degrees. So I know this angle right here must be 60 degrees. So that's how you use your protractor to actually find the length of the measure of an angle. You actually line it up. Sometimes they don't give you really nice numbers. Sometimes you might have an angle and it doesn't actually go through a whole number. The side lines up here, and the other side would do something like this. It might go through the middle of these. So in that case, you have to estimate what that is. Okay, that looks to be obtuse because if it started here and went all the way over to there, it's definitely obtuse. So it's bigger than 90. So it's got to be the bigger number. And you got 120 and 130. It's in between 120 and 130. So I would guess that's about 125 because it goes through that middle point there. So sometimes you have to kind of figure it out because they didn't give you every number on this number line. On this arc, they only gave you like the tens. So you have to figure out where it is in between those tens. All right, so that's how you use protractor to figure out the measure of angles. All right, typically you need 3 points to name an angle. All right, and the reason why I say typically is there's certain cases where you only need 1 point. but typically you need 3. For example, if I want to name this angle here, I'm going to call it angle 1. Alright, so if I look at angle 1, another name for angle 1 is angle ABC. Or you could do it in the other direction. You could call it CBA. Again, B has to be in the middle because that's where it bends at. That's the vertex of it. And either direction, you still name the same angle. So you typically use 3 letters, and the middle letter would be the vertex. Sometimes you use numbers, though. So I can call that angle 2. They just say angle 2. And it's sometimes easier just to rename all your angles with numbers. So you don't have to follow all these letters around over and over. You can always say, forget this. I'm going to call this 1, call this 2, and call this angle 3. And for now on, every time I look at the angle, I just say angle 3. And it's obvious I'm talking about this angle here. Everyone can see it, and you're talking about the angle there. Or if you want to name angle 3 letters, you could call that angle 3 or angle DBE. All right, so in the cases that you don't need 3 letters, it has to be like really obvious, and you can't be confused. Like if I gave you this picture, call this F, J, K, W. And let's put 4, 5, 6, 7 in there. So there's 2 names for those angles. All right, so if I looked at this, if I said angle K, well, everybody in the world knows what I'm talking about. It's clearly angle K is this angle right here. Or you could call it angle 6. You could have also called it angle, all right, move it elsewhere. Could have also called this angle K, could have called it angle JKW, right? JKW, or WKJ. All those name the exact same angle, which is angle K. But we could have used 1 letter here, and the reason why is it's not ambiguous. Ambiguous being capable of being understood in more than one way. K is clearly the only angle there, so you can't really, you can call it K if you want it. However, if that side was extended, like this, now, if I said angle K, let's raise that a little bit. And let's put a little point K there. Some other letters out there. If I said angle K, I could be referring to angle 6. I could be referring to angle JKN. Or if I say angle K, I could be referring to angle NKO. I could be referring to this angle here. So I could be referring to lots of different angles. So I couldn't call it angle K with 1 letter because it could be confusing. So you can only call it 1 letter if it's only 1 angle there and it can't be confused to be the wrong angle or some other angle. All right, moving on. You might have been noticing the curves I put in these angles. Anything with 1 curve will be congruent to any other angle with 1 curve. If I saw angle 2 and I put 2 curves there, to say that was equal to angle 3, I have to put 2 curves inside angle 3. So by having the same number of curves in geometry, that means it's equal to anything else with that same number of curves. So you have to be careful because 2 curves, if you have 2 curves, it automatically means those 2 angles are congruent and not equal to the one with 1 curve. Well, they could be equal to each other, but we don't know for sure yet. But if you see 2 curves, it definitely tells you they're equal to each other. So you have to just be aware of that. Last thing, I pause the video and write down this question and draw the picture someplace. Now, if you unpause it, I'm going to start talking about it. So go do that now. All right, in the picture, they said that if angle ABC, or actually if the measure of angle ABC is 2x plus 1, so ABC, this angle is 2x plus 1. The measure of angle CBH is x plus 5, so CBH, this angle here, I'm going to give it 2 curves, so I know they're equal, it's x plus 5. And they said also that the measure of angle ABH is 117. This whole angle is 117. All right, what's the value of x? So pause the video and see if you can find out. I'm going to give you an explanation for it now. You should have said that 2x plus 1 plus x plus 5 equals 117 and got x equals 37. I got to explain that in class. I'm out of time. That's all I have. Good luck.